The surface area of a sphere is 4 pi times its radius squared, exactly 4 times the area of a circle with the same radius. But why? Archimedes had a very beautiful proof that this surface area is the same as the area of a cylinder that encloses that sphere, if you disregard the circular caps of that cylinder. The idea is that if you shine some light from the z-axis perpendicular to that axis, then if you compare the area of a small rectangle drawn on that sphere to the area of the shadow cast on that cylinder, those two areas turn out to be the same. This isn't obvious, but when you work it out, that shadow is a copy of the original little rectangle, but squished down in one direction and stretched out in another. When you analyze the relevant geometry, the two effects actually cancel out perfectly. Treating the sphere as a sum of all of these little patches, and the cylinder as a sum of all of those shadows, we can infer that the surface area of the sphere is the same as the area of that cylinder. Now, the cylinder is something you can unwrap into a rectangle, where one side length corresponds to the circumference, 2 pi r, and the other corresponds to the height of the sphere, 2 times its radius. This gives us the area we want, 4 pi r squared. And if you're also familiar with the trick of showing a circle's area by unwrapping it into a triangle, one whose height is r and whose base is 2 pi times r, you can see how 4 of those unwrapped circles fit perfectly into this unwrapped shape.